introduce, I suppose most of you know, our community leader, Miguel Martin. So Miguel, the floor is yours. Let's get started. Thank you
Okay,
so much.
thank you, Katerina. Yeah, so welcome back, everyone, to this first meeting we are going to have in 2023, this new year. It's February already, but we have been a little bit late. We didn't have time to actually prepare something for January. But anyways, here we are with our speaker today, Juan Carlos. And let me actually talk about a few things before I pass the word to him. So first thing I would like to highlight, this is going to be our fifth talk since we relaunched the community back in July. We are already close to 500 engineers in the community. That's super good. Actually, we multiply our numbers by 4 in just 4 or 5 months. So it's super great numbers. Let's hope that we can continue growing this year. For doing that, we have plans to actually have 2 new activities for this year. One of the things we have been working is our new YouTube channel, in which we are going to try to not only have it as a place in which you can check on past meetups. Let me silence someone. Good. Yeah, so you can find there not only your past meetups that you can find also in the We Are community platform, but also we try to generate videos of new technologies, or we are going to try to do some interviews or generate some interesting content for you guys. So please check it. I'm going to copy the link in the chat. If you want to subscribe and keep an eye on the videos that we are uploading from time to time, I encourage you to actually do so. Apart from that, if you are interested in, as I always say in these talks, if you are interested in to actually give these talks to your peers in the community, please contact me. We will find you a date. We will help you with actually preparing your presentation and everything. Also, if you want to actually collaborate with the community, but you are not interested in giving talks, or you are shy and don't want to actually talk in front of people, it doesn't matter. Contact me. I will give you some work you can help me with. You can prepare videos in the YouTube channel. You can create articles. So if you are interested, come to me and we will talk about what you can do. Remember that all the activities that you do for the community are eligible for, or most of the activities that you do for the community are eligible for bonuses. And also you will receive badges in the Heroes portal, etc., etc. At least for the people that work at EPAM, but for the people that come from the outside and is working in other companies, we can talk about how can gratify you for your work for the community if you are interested. All right, and apart from that, just remembering you that after the meeting today, I will choose one random person from the ones that came today to the meeting to actually have one of our goodies. Is going to be a bag with a personalized cap from the engineering communities, and I will pick an email from all of you and contact him or her to actually send you this gift, okay? And without further delay, I'm going to present you Juan Carlos Valderrama. Juan Carlos Valderrama is our speaker today. He's EPAM solution architect. He's going to talk us today about CloudFormation and how to automate infrastructure in AWS. So Juan Carlos, the floor is yours. You can begin your presentation.
Very well. Thank you so much, Miguel. Welcome everybody to this meeting today. So just like Miguel was saying we were talking about CloudFormation, right? That we are saying here. Just to introduce myself pretty fast, I'm having a lot of time in technology as well as white hair. And the most
Juan
important here,
Carlos, I don't know.
yeah,
I think you are sharing the other
okay,
monitor, the second one.
right. What about now?
Yeah,
Better?
that one. That's great.
Thank
Perfect.
you. Thank you. So apart of the white hair and a lot of time, the most important thing here for this meeting is I'm already certified as solution architect as well as instructor in AWS topics, right? Today we are going to onboard a topic that usually the organizations race against the cloud architects for solutioning any problem. And the biggest problem they have is how to improve the process of deployment infrastructure, considering that everything in AWS is an API environment, as well as everything is software defined. There should be a way to improve the time of deployment any kind of infrastructure. So the chief technology officers just reach us out as consultant and ask us how can we simplify our cloud infrastructure build, and even how we can deploy, maintain, and scale applications in the cloud, right? For that, our agenda today is quickly define what is a infrastructure as a code or AAC, then see what is CloudFormation and how it works, how to define a template of CloudFormation manually or using the designer. Then we'll see a demo that I previously preloaded in my personal account in AWS. And then we wrap up with the best practices and more AAC tools that we have on hands to use, right? Later, we will give you a couple of minutes to you. Please bring us some feedback and bring your questions regarding this topic. Now let's get started. What is infrastructure as a code? It's a term that all the time we are hearing in the cloud world, but basically the infrastructure as a code is the way in which we define based in a template or code what infrastructure we want to deploy it. And such template, it's interpreted by a tool usually called infrastructure as a code solution tool. And at the end, the outcome is the infrastructure that we can define or deploy inside of the cloud. But such a tool must comply with some final prerequisite. The first one is it can be allow me to replicate, redeploy, and repurpose the template. This simplifies the time that we have to use to deploy the infrastructure. Then, considering this is a template which is written in code, we must be able to control the version of those templates to replicate, redeploy, and repurpose the templates based on our needs. Finally, the tool has to be capable to detect drift. This means undesired change in the infrastructure already deployed. And finally, the tool must be capable to allow me make a rollback pretty fast without a major downtime or outage in our infrastructure. Yeah. For that, AWS CloudFormation works in stacks. Stacks then is a collection of AWS resources managed as a single unit. This means the unit is the template itself. This feature allows AWS's CloudFormation works with different stacks that I can define nested or I can define as a standalone infrastructure. In the example of the screen, you can see then that I can create different stack based on different needs. For example, this first one is just networking. The next one is just the data layer. And finally, I can use the compute part in separate stacks that can interact together each other, right? In this case, stack is the definition for the local deployment. If we want in AWS to deploy regional resources, we have to use a stack set, which is to allow the template be available in any region in order to simplify the deployment. If we do not use a stack set, but instead we use just a stack, we have to copy and paste in every region the template that we want to use, right? Then when a stack is deployed, right? If I want to reuse it or repurpose it, I need to create a change set. The change set is the way in which CloudFormation can control the versionings, but inside of the AWS, the versionings that we are running from the original stack. So every time I rerun the original stack with new changes or with updated, it will be created a change set. And this is very important because the change set is something that I can approve manually or automatically, which becomes CloudFormation in a powerful tool for DevOps environment. And also, this feature helps me out then, as best practice, create layer architectures. This means in a real world, there is no one single team in cloud doing everything. Usually we have several teams that are dedicated with specific skills. For example, networking team, storage team, computing team, governance teams, and so on, right? So CloudFormation, considering that works in stacks and those stacks can be nested, you can then create a layer architecture in which you can use different templates that can fit the next one with the output they provide. How CloudFormation do this? Basically, CloudFormation is a template that can be written in JSON or YAML. I do prefer YAML because YAML basically allows you to make comments and JSON not, right? But basically, it's a template written in JSON or YAML that had the following sections. You can have a description sections. You can have a metadata section just to write down comments for informational purpose. You can create parameters. You can set mappings to convert information. You can create conditions. It's very important because you can define here if your template can be for dev or production. By just simplify the code, this means 80-90% of the template can be reused, and with the condition, you can define if the template will be deployed in development or will be deployed in production with minimal effort. Also, you can make transforms, right, in which you can transform, for example, one resources into another or keywords into another. Even you can create models to reuse configurations inside of the template. And finally is the resource section, which is the only mandatory to run a AWS CloudFormation template. Just for your information also, there is another section called outputs. The outputs are very convenient because that's the way in which you can export the outcome from the template for other stacks. So the outputs can be the inputs of another stack, right? Just moving forward, let's check a demo that I already predefined in my personal console. So just a minute, let's see if we can see it on the screen. Okay, I'm seeing it here. So previously, I recreate a stack. First thing, let's see how a stack is created, right? I click on create start, and there are different options. Option number 1, the template is ready. Option number 2, I'm training myself in CloudFormation so I can use predefined templates that AWS brings to me in order to start over learning how CloudFormation works. And finally, I can create a template in the designer if I want to use a graphical interface to create my infrastructure. For this session, I will use a template which is already created. I can save such template inside of a S3 bucket, which is the best practice, or in this case, for lab purpose, I will use a template that I have on my desktop. So let's see, just a minute. Okay, I will upload here. So the first thing that I want to show you is I can click on designer, right? And the template will be transformed into a graphical representation of the code. If you see here, all these blocks are the ones are recreated in the code. Also, CloudFormation can help you out to transfer from YAML to JSON and vice versa, but be please aware of this. If you have comments in YAML, those comments will disappear when I transform to JSON. Also, I can make the reverse engineering here too. For example, I can take one of these blocks, add it inside of the designer, and I can create everything in here if I'm not high proficient in the code for CloudFormation. Technically speaking, this CloudFormation example, we create a couple of subnets inside of the VPC with two NAT gateways and all the network layer connectivity for preparing for a project. This is just only for the session purpose. So I just already run it just to show you how it works. Then let's recreate again the template. Just a second. Let's do this and this. It's very important to understand that I can create here, right, my stack name. And as far as you can see, I can predefine parameters that can be free or predefined, just like in this case. This helped me out to avoid the human error in the typing of the information. Then I can define the metadata for this, which is described in the template that we already shown. Let me show you a little bit the code of this in a graphical way. All right, just to demo the part that we are seeing here. So if you see, for example, this part of the code says CIDR block for the VPC is a string. It has a default value, but also I can restrict the values that I can type inside of the template. So if we see here on the screen, you can see it then in one of these parameters. In this case, is this one. Notice that CloudFormation will not have by default a order, right, to write down this. Usually is the alphabetical order, right? But not all the time is being respected because it's not mandatory to have a specific order, even deploying the infrastructure. If you require a specific ordering when you are deploying the infrastructure, you can use a command called depends on inside of CloudFormation. Then let's click on next. I can define up to 50 tags, right, to check and add metadata to my infrastructure. I can decide which role will be used for audit purpose deploying the infrastructure, and I can define what will be the stack failure options. This means roll back all the stacks if everything fails or something fail, or just preserve the successful ones. I do recommend as best practices, you always use rollback all stack resources, because if you nest your infrastructure deployment, obviously it's better to roll back everything and try again instead of make some patches. Also, you can create a stack policy, right, to define who can modify or even delete this stack, right? And there are time to define how much time the deployment can run, right, without successful. If after, for example, 10 minutes, the deployment is not finished, it can be considered fail and it will be rolled back This is very important because this is the way in which we can make more efficient our process. It's not worthy to have a process running 2-3 hours, right? It's not good for the business. So we can usually use minutes as a good parameter to define this. When I click on next, then CloudFormation, what we will do is validate all the structure of the CloudFormation. If this page succeeds, it's because the unit test inside of the code, it's okay. This means the template is well written. This means, once again, the resource block is present and the other ones, just like parameters, metadata, transformations, so on, are well written. If I click submit, the process already started, but considering the time constraint of the session, I already made it for you. The first thing that we have to check here is, obviously, I create and delete the stack, but in this case, when the stack is run, you can see the status uh, um, create complete in green. In this case, is delete complete because I already created and deleted, but I can click here and see all the detail of the stack. What we are seeing here, first thing we see is a summary about what I did, right? And most important, the drift status. We will drill down a little bit in a few minutes on this regard because it's very important. It's a very powerful feature we have. All the metadata and description that I have from the stack. And every time the stack runs, it creates a comment, right? Creating progress, and it's been showing just the logical ID. This means the metadata of the name that I put in the resource, as well as the time and date, the timestamp used when the resource is created, right? If you see here, more above, you can see, for example, that let's see, just a second. In here, if you see, my demo stack was created a few minutes ago today, right? And the resources were created. When the resources are created, okay, all of them are listed in the tab resources. You can see the name that you put it as logical ID, the physical ID. This means the ID name that by default AWS proposed, and the type of the resource that you create. In this case, it was a security group, a subnet, the root table associations, and the status. If I go down a little bit, of course, everything is deleted because, just like I explained at first, I upload and erase the resources just for financial purpose of my own pocket, you know. Then one of the most important features, the outputs. If you see, even when I create a lot of resources here, I'm just deciding which outputs will be exported as variable. These outputs are not just for informational purpose. These outputs can be used for other stacks and be reused in order to nest the next part of your process. For example, in this case, I was creating the network layer, but maybe you need the computational layer, right? So the computing layer can use security group, in this case, the application security group, just to create the instances and so on. Finally, you can see the parameters that I type to create the stack and the template I use. If you see, it's exactly the template that I show you up as code before. Very important because you can check here all the code. For example, if you create a stack just like I did from my desktop, but you lost the information, right? You can recreate your YAML file or your JSON file from this part. And last but not least, the change set. In this case, I did not update the script, but if I rerun the script, what you can see here is a change set waiting to be approved. Very important for the DevOps process because you can nurture your process to define what will be the approval process. Finally, to conclude in this demo, we can see here the drift version. What it means drift? Drift is when someone manually or externally modify the infrastructure that was created with the stack. Very important. Only drift works in any AIC tool if you change infrastructure or features from such infrastructure that were recreated from your script. If the feature of your infrastructure was not created by your script, there is no tool that will identify or detect the drift. In this case, in the example, the drift was made on an Elasticsearch subnet group. What did I change? Just the name. Let me show you. If you see here, right, what I changed manually was the name in the capital letters. So drift is so sensitive that we'll check all the lines of your template and validate against the current infrastructure deployed, and it can tell you precisely what it changed. Probably inside of the organization, there is a process that requires the capital letters to identify at tagging level your resources. So it's very important. In this case, a simple change, just like the capital letters, are detected by CloudFormation here. Okay, then let's go back to our presentation then to wrap up. So as far as we can see, everything inside of the CloudFormation is created: the NAT gateway, the public subnet, the application subnet, the database subnet, into availability zones, and inside it was created also the route table, the network access control list, right? And the security groups inside of each one of these applications. That's what we saw in the demo as resources already created, right? Now, what would be the best practices that we can use here with CloudFormation? Because CloudFormation is very cool, but you cannot just go freely and create the scripts without best practices, because it will open some security matters or non-compliance matters inside of the organization. Basically, we have the following best practices. The first thing, planning and organizing, right? As shorter your script is, as faster can be reviewed and versioned, right? Just like any code. So just make short your script. No thousands and thousands of lines. It will be hard for the organization, may follow up and correct soon, right? Also, organize them by lifecycle and ownership. Define, for example, stacks for networking, stacks for governance, stack for computing, stack for storage, and so on, depending of the organization, and create them life cycle, right? For example, every week you need to make a change or version, right? Also, use cross-stack reference. Let's always use the output part. It's the best practices. If you don't use it in other script, no problem. As best practice, always create the output part. Use identity access management roles to control the access. Who can delete this? Who can modify this? Not everybody must have access. Use the least privilege concept or the least privilege principle in security-wise. Reuse the templates. This means use the condition part to define if the template can go for development or can go for an application specific or even can go for production, right? This will reduce the amount of code that you have to use and create for any environment. And verify the quotas of all resource type, because you can create thousands of CloudFormation scripts, but your account has a limit for a computing, has a limit for a working, has a limit for storage, and so on. Not just financially, but also technically. For example, network access control rules only supports 40 inbound rules and 40 outbound rules. So if you create that template in CloudFormation with 52 rules, obviously the same will not run. It will fail and you will not be able to know why. And use models to simplify and reduce the configuration. CloudFormation allows you to create models, simple templates that you can tag inside the CloudFormation registry to be called from your CloudFormation template and reuse them in several ways. For example, you can create the computing layer, right, and configuration in every instance as a model. So every time someone uses a CloudFormation can call that model instead of write down the entire code for the computing. When you are creating the templates, try to simplify your code and standardize it as much as possible. For example, security rule number 1, do not embed credentials and use dynamic reference instead. In this case, we are seeing here a variable that is calling a secret, right? In a system manager, secret manager parameters, right? Also use AWS specific parameter types. This means every resource has specific parameters. So instead to create custom functions to get the information, just invoke the parameter of their resource. And that's it. Simplify the code for that. And also restrict how the inputs will be added in the script. For example, you saw in the demo, I already predefines the IP addresses, CIDRs that can be used, the region, the subnets, or even you can define everything can be in capital letter or everything can be in lower letter, or if the values are strings or if the values are numbers, etc., just to ensure the error prone does not exist. Also use pseudo parameters. Pseudo parameters are predefined and global parameters that CloudFormation already has. For example, if you're running your script in a specific region, there is no need to write down the region inside of the code. Instead, just use the pseudo parameter AWS region, and that's it. AWS will catch the region from where the script is running, and that's it. You're saving code instead of hard coding everything. You can use the flexibility of pseudo parameters for this regard. And just for EC2 instances, there is another part in which you can simplify even more the code. You can use the function AWS CloudFormation init that will help you out to construct predefined configurations for every instance. So instead of repeating the code all the time along the cloud stack, the CloudFormation stack, you can use AWS CloudFormation init to invoke that code, right? Sounds logical, but please validate the templates before using them. You can use the console or you can use the AWS CLI to run the commands that let you know if the script is well spelled, well written, and can pass the unit testing. Finally, when you are managing the stacks, right, always manage all the star resources to the same tool. In this case, manage everything through CloudFormation, right? If you do it outside, it will be very challenging because you will have custom configuration that cannot be easily portable to another region or even another environment. Create change sets before updating your stack. Instead of asking for the changes directly, always create that change set to provide the organization the opportunity of validate and approve or reject the change, right? Just like a change management best practices. And finally, use policies, use AWS CloudTrail to make audit along all the activities are being done inside of AWS CloudFormation, and use the typical code reviews with your peers, as well as you can update your Amazon EC2 instance regularly. Remember, EC2 change every time. So today we have a family of EC2 instance, and tomorrow we will have more powerful EC2 family, so you need to review your code again. Is CloudFormation then the only solution we have for infrastructure as a code? No. Inside of AWS, there are more tools, but CloudFormation is the basic one, and in fact is the core of infrastructure as a code inside of AWS. Couple of tools that we can review on top of CloudFormation is Elastic Beanstalk, which is a service that given an application code or a type of code, for example, Java applications, Python applications, AWS can propose you the infrastructure you require. If you want, for example, not start from scratch, but start from an example of proven solutions as per industry, you can use the AWS Solution Library website. Or even if you can use something, some tool similar to Terraform, for example, which is some kind of CloudFormation but written in blocks. Yes, it's more code oriented than the CloudFormation. Instead, you can use AWS CDK, which the flagship product is Cloud9, is the IDE for AWS CDK, right? Now we discuss AWS CloudFormation, and finally, after deploying your infrastructure, you can control it with AWS System Manager. How I decide as architect what will be the proper solution for me? It depends. I'm risk tolerant to lose the control and work just based on speed. Use the most convenient tool, the fastest one, Beanstalk. But usually big companies loves control, right? For audit purpose. If you love the control or you need the control, definitely you just can work on CDK or CloudFormation. At the end, everything you write in CDK will be translated to AWS CloudFormation. In here, you already heard about what is infrastructure as a code, how CloudFormation works, what is a stack, what is a stack set, how you can run a CloudFormation, finally the best practices as well, other tools that you can consider to deploy infrastructure under the concept infrastructure as a code. Now, I would like to hear from the audience if there is any question, any doubt, or any clarification you would like to raise in order to give me the opportunity to explain or clarify what you require. So for now, thank you for this presentation, and let's pass to the questions you might have. So be my guest. The chat is open. The microphone is open. Please let me know what you want to know.
Yeah, hello. First of all,
Hello.
thanks, Johan, for the presentation. I wanted to ask a question regarding the capabilities of the CloudFormation. Is there any limitation that CloudFormation cannot do comparing to things that we can do manually via console or AWS CLI?
Yeah, absolutely. Great question. Well, the limitation that technically CloudFormation has is the amount of stacks that you can use inside of an account, right? In fact, CloudFormation can do more than the client itself, right? Limitations that we are talking about right now is just at account level. This means it's more than, if I recall it, more than 1,000 stacks inside of the same account. For the rest, there is no other limitation than that.
But as far as I'm aware, previously it was a situation when you cannot specify things the same that you can specify in CLI. For example, for EC2 instance, you cannot specify the SSH key, as far as I remember. There are some other limits regarding different subsystems, especially the new ones. And is the situation changing? Is it like fully available? All the features are fully available now?
No, and the reason is very clear. Is that because let's remember the best practices. You cannot embed credentials and dynamic and instead use dynamic reference. In the AWS CLI, you can use the SSH key directly, but that SSH key will disappear as soon as you go out of the client, right? But if the CloudFormation, if you embed such credential inside of CloudFormation and you lost the CloudFormation part, you will jeopardize in the entire organization, right? So that's the reason why it's not allowed inside of a CloudFormation put credentials. You can type it if you like. You can type it, right? But it's not a best practice. In fact, if you go to the EC2 instance and you, through the CloudFormation, type the Linux command or the Windows commands, including in a text the key, it will be taken. But the problem is you will expose your organization, right? That's the reason why it's not a best practice.
Yeah, got it. Thanks. And the last question is, everyone knows that there is such thing as Terraform. Why would a person doing like multi-cloud or AWS alone even would prefer to choose and limit his functionality only to CloudFormation and not go with Terraform?
Excellent question.
Yeah.
Please, yeah, finish.
Yeah, are there any kind of killer features of CloudFormation comparing to Terraform, for example?
There are two different things here. CloudFormation, the opposite. Terraform, at the end, convert the code into a CloudFormation. In fact, if you run your Terraform script and then go to AWS, you will find a CloudFormation inside of the AWS. You mean it's not one tool killing the other one, right? CloudFormation, of course, requires more line of codes than Terraform. But if you don't want to write down too much line of codes, you can use Terraform, which is very popular inside of AWS, or you can use its equivalent from AWS, which is the CDK, Cloud Development Kit, right? It's much the same. So one tool is not killing the other one. At the end, a Terraform script is just a simplification of CloudFormation. And when you run your Terraform script, you will see a CloudFormation inside of AWS.
Okay, got it.
Asking that question, there is one, that's a typical question that people do about Terraform. And there is one big reason that actually companies, the cloud companies gave to this, and is Terraform doesn't support all the features, or the rate of incorporating new features is not as fast as CloudFormation or native tools. Because you depend on what is already implemented in the provider that you are using. Usually it's like 90%, 95% of all the tools that are in the AWS or Azure, but it's not 100%. So depending on what you are trying to deploy, maybe you need to actually go to CloudFormation because Terraform is not yet or cannot yet use these new capabilities or whatever. So that's another option.
Thank you, Miguel. That is a very good question too from Albert. It is possible to import existing resource to CloudFormation? The answer is yes. You can make reverse engineering in there. You can try with AWS CloudFormation, read the resources that you already have created, and then you have to refine the script in order to make that registration. But it's possible to make that reverse engineering.
Yeah, also Yuri is saying in the chat that rollback possibility in case of bad deployment is one of the killer features that with Terraform you should actually do Terraform destroy. Sometimes it gets inconsistent. So
yeah, that's correct. That's correct. More questions from the audience, please.
Maybe what kind of deployment approach for CloudFormation could be used, or for CloudFormation changes, or how to deal with dependent stacks and their changes in CloudFormation.
Would you mind to provide an example?
If you have dependency between parent stack and child stack, and if you change something in the parent stack, you could be getting stuck because child stack is depending on some kind of resource that you modified or deleted in the parent stack, and this could be a problem.
That's correct. That could be a problem. And the way in which you have to sort it out in production is to use a configuration management tool. In this case, you can use inside of AWS System Manager. System Manager can help you out along with AWS Config, and as well another high-level tool just like AWS Tower, Control Tower. You can use those three from the governance and infrastructure perspective, validate any change in the configuration, especially AWS Config, as well System Manager. Together are very powerful to check which configuration is changed and the dependencies inside. But CloudFormation per se does not have such capability because it's not a configuration management tool.
I see. Okay.
One more question. Can stack in one region do multi-region deployment? Yes, that's the concept of a stack set, Albert. If you create a stack set, you extend the capability of CloudFormation from local to regional.
Just one question from my side. I suppose that from the CloudFormation, you're able to access AWS KMS to actually get necessary secrets in case that
Correct.
You need them.
Correct, Miguel. In fact, that's one of the best practice that I highlighted here. It's because you can use dynamic variables instead of a static variable, but that's correct.
And another small, detailed question about the syntax of CloudFormation. I remember like a year ago or something like this, I was struggling to make the CloudFormation template run like 10 multiple instances from one declaration, like create multiple resources. Did the situation change? Does CloudFormation allows you to run like any dynamic number of resources you specify in the template?
Yeah, that's a great question. CloudFormation by itself, no, but you can make complementary action just like integrate CloudFormation with Lambda. In fact, inside of AWS documentation, there are several use cases in which you can use a Lambda to define dynamic inputs for each deployment.
Okay, or use the CDK again.
But once again, CDK purpose is to reduce the line of codes that you have to use, but with the challenge that Terraform already has and Miguel highlight. Yeah, not all the flexibility that you have in CloudFormation is present in CDK, because CloudFormation is drilled down at very low level, every one of the features of every resource. But CDK or even Terraform are stick just to an amount of features, right? And not all the flexibility can be found in there, right?
Okay, got it. Thanks.
Sure. It says, Yogesh, I'm using admin access for creating AWS resources, so I don't come to no restriction on policy. Is any way to pre-check what are the AM policies to create resources? Yeah, absolutely. If you see in the AWS CloudFormation documentation I'm showing on the screen, you can find in there which AAM policies you can have. For example, in troubleshooting, you can find here several guidelines how to do that, right? Obviously, CloudFormation, let's remember, cloud is a world of APIs. So if you see the API guide for CloudFormation, you will find what will be the AAM policies that you need to apply for that. In fact, you can protect the stack for not being deleted for anybody, just one person. All right, you guys? Well then, is there any way to do something similar to plan? Yeah, in fact, there is a layer called AAM capability. It's a feature that has when you invoke CloudFormation, Miguel. So you can use specific policies to run the stack, and if that parameter is not predefined, the stack will just fail just because of policy purpose.
I think Miguel was asking about the final kind of changes that are displayed in the Terraform plan when you do it, and it shows you what resources with specific parameters will be changed in the infrastructure. And as far as I remember, in CloudFormation, there is no such thing as like showing you the resulting your plan.
All right. Well, one thing, yeah, it can be done. If you see it in the stack, every change you make, well, I did not upload that part in the demo, but when you rerun the same template, is being created a change set. Yeah, do you remember the change set concept? Let me see if I can have it here. Yeah, the change set concept is the same. It's a plan. It's the equivalent to Terraform plan, right? But just for CloudFormation. Let me show you here on the screen. This change set, right? So you can run the original stack, and the second time you run the same stack, CloudFormation will validate the change and will show you what will be the changes, right? We'll show you the template, the new template.
Before they were deployed.
Before. Yeah, exactly before. You will see on the screen. Sadly, I not have it here, but you will see on the screen. Let me show you. Do you remember that in the stack we have this template part? Right? When you create a change set, you can see here the changes, right? You can see in parallel the original against the new one, because that's the way in which the tool identify the drift, right? You can identify the drift before with a change set, and you can identify the drift after the deployment, just like it happened in this case when I change from lower letters to capital letter the name of our resource. Right?
By the way, the original Terraform plan is not available in CloudFormation. You have to deploy at least any kind of resource, any simple resource, and you could create change set and verify the difference between the deployed and changed or desired configuration. However, in CDK, it is possible. It shows when you create CDK diff, when you run CDK diff, it shows you what will be changed or deployed, so far, so on, even from scratch.
All right, thank you for such contribution. Any other question the audience wants to know about CloudFormation or the session that we already ran? Looks like no. So Miguel, audience is all yours again.
Okay.
Thank you, everybody.
That was a really interesting session, Juan Carlos, and also really, really great question and answer session in the end. I think it was one of the longer ones that we had. That actually shows how interesting was the topic. So thank you, Juan Carlos, for the talk. It was really, really great. And just a few words from me before we close. Guys and girls, remember we have in the beginning of the chat, you have the links to the page of the talk in which you can actually show appreciation to our speaker, to the moderators, to the people that actually help us with the organization. And you can also rate the talk. And also you have the link for the new YouTube channels in which we will upload this the video of this session when it's available. So thank you everyone for being here today, for being with us in this session. And I hope that you actually join us in the future in future sessions. We will try to actually bring you more interesting topics for all of you. So thank you everyone. Thank you, Juan Carlos, and see you next time. Bye.
See you. Bye-bye.
Thank you.
Bye.
Bye.
Thank you.